So x is greater than negative 1. But what if it's negative 0.5? Or negative 0.3? So you're so close, Libby.
X is greater than 0.
Greater than or equal to 0. Right. So if it's not negative, it means it has to be a positive number. Positive numbers start at 0 and they work up. So greater than or equal to 0. Write an inequality that shows that x plus y is less than or equal to 25.
X plus y is less than or equal to 25.
Yeah.
I'm so good at
So
math.
change the less than or equal to wording into symbols. Number 3, which quadrant of the coordinate plane, so that's that xy axis, it's called a coordinate plane, is represented by the inequalities x is greater than or equal to 0 and y is greater than or equal to 0. So if you think about having an actual graph, here's my y equals 0, and here's my x equals 0, and Ethan really wants to go.
Oh, now I'm going to get it wrong. Second?
So if it's greater than or equal to 0, that would be
Okay.
this area here for y. If x is greater than or equal to 0,
Wait, it's greater than? Okay, no, it's 1.
it's this area here. And so the region that is intersecting, Ethan, is 1.
I read it
Remember,
wrong.
when you're talking about your quadrants, 1, 2, 3, and 4. When these graphs were created, they were created with Roman numerals. So no, you don't have to use Roman numerals, but that is actually how they were created. So before, like, numbers were really a system, there were the Roman numerals. But the first quadrant is this positive quadrant, and that should be the quadrant where your graph would exist if x was greater than or equal to 0 and y is greater than or equal to 0. So essentially that's saying that you can't have negatives in the graph. So there are no x values that are negative, no y values that are negative. So then the last one, I asked you to change that inequality symbol to be less than or equal to. And I want you to describe the shape of the region containing the solutions. So if that is x plus y is less than or equal to 25, and we solve that equation, what would that equation look like if you solved it for y? So x plus y is less than or equal to 25. What's that equation in y with y by itself?
Y is less than or equal to negative x plus 25.
Right. So y is less than or equal to negative x plus 25. So if you think about a graph, we just said above that the graph has to be in the first quadrant for x and y to be greater than or equal to 0. So that puts us up here in this region. And then if I graph 25, that's somewhere up at the top. A negative slope means that the line does what, Chelsea? It decreases, so it's going to go down. So the shape that you would get would be then this shape here, which is a triangle. So these two lines, the x and the y being greater than or equal to 0, are forcing it to be in the first quadrant. And then the fact that it's x plus y, that really should be a less than or equal to 25. Otherwise, you don't have a shape. If it's less than the line, it's underneath all the points on the line. So that creates a triangle. The last question there says, would the points on the line be a solution to this system? So if I have a point on this line, would that be a solution? Tina?
Yes.
Yes. If it was between or in the first quadrant. So if it's on the first quadrant, or if the values are positive, then yes, it's a solution. But if it was a negative x, then it wouldn't be a solution. Or if the y was negative, it wouldn't be a solution. So it's only a solution for the positive x values of the line, or the positive y values of the line. So a portion of it works, but not the whole line. Questions? If it just said less than, then none of the line would work. So if it was just x plus y is less than 25, it wouldn't be a part of the solution. It would be a dashed line, and that means none of the points on that line would work. All right, so we're going to go over number 34 yet. But before we get to 34, if you look at the bottom of this page before you put it away, this is part of your homework. So part of the homework are these 4 problems. So you'll be graphing them, and you'll be then labeling the vertex of each coordinate, or with a coordinate, and we'll talk about doing that today. But so those 4 problems are part of your homework. And then in the book, there are 4 more problems. Only one of those 4 in the book you're actually graphing. The other 3, the graph is already given for you, and you're going to be using the graph and doing some things with the graph that's already given. So you should really only need 5 graphs. And I did mine just before lunch, and it should not take you very long to work through. So if it does, come and see me in the morning. But I did mine in about 10 minutes. I don't expect it to take you 10 minutes, but it shouldn't be too much. Questions? All right, so let's look at number 34 then. 34 was the word problem. Word problems obviously aren't going away. Tomorrow we'll be looking at a little more involved word problems. Today we're going to do like the intro to those problems. So you can work at most 20 hours next week. So you know that 20 hours next week, you got a pretty full schedule, and that's the most amount that you can work, no more than that. You need to earn $92 to cover your weekly expenses. You're a dog walker, which pays $7.50, and you have a job as a car wash attendant, and that's $6 an hour, which apparently it's better to be a dog walker than to dry off the cars at the Northway car wash. So write a system of linear inequalities to model the situation. So we have 2 variables. The x would be your dog walking job, and the y would be the car attendant. Okay, so how about coming up with an inequality to represent one of the pieces of information up there? Nina?
I said x plus y is less than or equal to 20.
Yeah. So x plus y less than or equal to 20. That's telling you that your number of hours as a dog walker and the number of hours as a car wash attendant has to be less than or equal to 20 hours, not greater than, because at most means it has to be less than that number. So this takes into account your 2 jobs and the total hours that you're working at those 2 jobs. The second one, Dylan R., how about the second one? So how much money are you making as a dog walker?
Dog walker is 7.5.
Yeah, so 7.5. How much are you making as a car wash attendant?
6.
6. And how much money do we want to make? 92. It says at least, so greater than or equal to 92. You didn't have to graph that one. You were just asked to come up with the system of linear inequalities to model the situation. Any questions? No? Good. So in your packet then, if you'll turn to page 15, we are going to be doing some graphing today. You might want to use the shading with the color pencils. You may realize that it's too much shading and you've got too many colors going on. It's kind of your call.
There's never enough shading.
Never enough shading. So page 15, please, in your packet.
Page 10.
Well, then maybe it's mixed.
17, not 15.
Yeah.
17, sorry.
I forgot about like whenever looking at Betty Walk or Betty Walker was like 7th grade.
All right, so between today and tomorrow, we're going to do something called linear programming. Our goal in linear programming is to take an application problem. So whether you're making 2 different things or you're selling things like the pizza, if we were selling the pizza, your goal is to see how can you either raise the most amount of money. If I'm selling pizza, how can I try and raise the most amount of money? Or if you're making something, how can I make sure the cost is at a minimum value? Because obviously the less you spend on an object, the more you're going to make in the long run. So linear programming is trying to look at the max and min values of linear inequalities. So we're going to be graphing just lines. There won't be any absolute value problems in it. It says it represents the constraints on a variable. We'll talk about a constraint. And then the goal is to find a max or a min. So today we're just kind of talking about it without the word problem aspect. And just to kind of show you how to work through a problem. And then tomorrow we'll put the word problem in it so that you can see what it looks like. And how to actually solve a problem with the words that we'll be dealing with, so the actual application. So 2 words up here, constraint and feasible region. What's another word for constraint? Begins with an R.
Restraint.
Kate? Restriction. So a constraint is the same thing as a restriction. So it's a restriction on a variable or multiple variables in the system. So for example, if I say x is greater than or equal to 0, I'm restricting the x to be positive. So in math terms, we call that a constraint. It's a restriction on x. Or if I said y had to be greater than or equal to 5, I'm restricting the y that has to be 5 or larger. So you're putting a restriction on the variable in the problem. It's called a constraint in math. We just had to pick a new name. Yeah, I know. Just math people. The other term is a feasible region, and that's where our solution is going to be, but that's going to be a bounded solution. So it's a bounded solution to our system. Bounded means that it has points that connect the lines. Those lines don't go on forever. So like the triangle, so if my graph looked like a triangle, I have these corner points that are bounding my graph, forcing it to be a triangle. So that's called the feasible region. So it's where our solution is. Our answer is going to be in this region that is bounded by the points of connection between our 2 lines. And those points are going to be called vertices. So in this case, there are 3 vertices of the graph. So down below, there is a space for a graph. With 3 problems in your homework, you're going to be given a graph. So I'm going to draw a graph. I'm just coming up with a picture, so we're not actually using equations or inequalities to graph this. But part of your homework, you'll be given a feasible region. So I'm making the feasible region up here. So if you want to plot points at 1, 0, and then this is 1, 2, 3, 4, 5, 0. And then 1, 4, and the final point is 4, 2. And then we're going to connect them to make it some type of quadrilateral.
Wait, why do we do that?
Okay, so you're going to be given a feasible region, just a graph that's already graphed for you. So we would use inequalities to make this graph. But instead of actually graphing it, the graph is already given. So this graph matches with some sort of system, whatever the system happens to be. So I'm saving you a step. Instead of telling you to graph 4 lines and find out where the solution is, this one's just given to you. So this is our feasible region. This is the solution to a system of inequalities that we would have graphed. But instead of us physically graphing it, we're just starting out with an answer. So this is like the answer to my system, the solution to the system. Our goal is to find the maximum and minimum values of the objective function. So after we have a graph, you're going to have some kind of goal to use the graph for. So why am I graphing this? What does it mean? Generally, there's going to be a word problem to go along with it, and that word problem is going to have some kind of goal or objective. So remember, your objective is what are you shooting for? What are we trying to reach? In this case, the objective function is c equals 3x plus 2y. Tomorrow it'll change. It might be profit, or it might, like c could represent cost. But this equation is going to change. That equation is just for us to use right now to see if I can find a maximum and minimum value from the graph correlating with this objective function that they're giving us. So to do that, you take the ordered pairs that are the vertices or the corner points of our graph. So the intersection points of the graph. Create max and min values from your function. So you can pick a point inside, and the point inside will be somewhere in the middle of your function, but it will never be the most or the least amount of whatever you happen to be dealing with. So my maximum and minimum values always come from the points that are on the edge of the graph. So in order to find if they're a maximum or a minimum value, you take the vertices, that's what those guys are called, and you plug it into your objective function. And again, right now it's just c equals 3x plus 2y. So you could say you're trying to find the minimum cost of something or the maximum cost of something. So literally you're taking the ordered pair, plugging it in, and seeing which one gives you a minimum value, the smallest value, seeing which one gives you the maximum value or the most amount. So today, it's just the idea of this is a graph already done for you. Can you find the maximum and the minimum value of the graph based off of an equation or an objective function? So an objective function is just the goal or our end result. So know that like 3x plus 2y isn't anywhere on this graph. That's just numbers to use later on so that we can try and find a max and a min. So Julia, 3 times 1 plus 2 times 0 is 4.
Three.
And there. And 3 times 5 plus 2 times 0?
15.
And then the next one?
12.
And the last one? What did you say?
16.
Okay. So when you're looking at this, if it wants us to find the maximum and the minimum value, I mean, obviously the minimum one is right here. The max was pretty close, but it's this last one of 4, 2 that ends up being the
That
max.
last one's false. 14.
It's 14?
No, it's not.
Oh,
3 times 4 is 8. Plus 2 is 14.
What?
3 times
Plus
4
2
is
is 16. So I don't want to
12.
Wait, he still got it right.
So 3 times 4, that ordered pair is at 1, 2, 3, 4, and then up 2. So 3 times 4 is 12, 2 times 2, 4 gives us 16. Questions on that? So if you flip to the top of the page, we're going to skip number 1. We're going to go to number 2.
I love skipping number 1.
Yeah, skipping number 1 there. So now this is where we're going to actually try and graph it. So we're going to see if we can come up with a region based off of the information. And it's called a feasible region, which is just really the solution that is a bounded shape. And it'll always be some kind of shape. Notice they leave you with C's and D's instead of X's and Y's. If it drives you crazy to have different letters, like your homework will have different letters on it, then change them to X and Y. How do you change it? So if we have C and D, how do we know which one's X and Y? Nina?
C is X and D is Y.
Why?
Because they are in alphabetical order.
Right, they should be in alphabetical order. So X, your independent variable, alphabetically goes before Y, which is the dependent variable. So C is really your independent variable because it's before D. So if you want to change all of these, so D is Y, C is X. And you're gonna have U's and V's in the homework, S's and T's, so feel free to change them if it drives you crazy to see them read
I'm keeping it the same.
You're keeping it
Me
the same.
too. I gotta be open-minded.
So the first thing that I'm going to do is to take this inequality here. It's called a compound inequality because there are two numbers and there's an x squished in between. And I'm just going to separate it into two separate inequalities. You don't have to, but it just might make it a little easier to look at. So if I'm reading the left side of this, it says x is greater than or equal to 1. So I'm just going to repeat that here. X is greater than or equal to 1. And then when you move to the right, start with x and go to the 4. The second one is x is less than or equal to 4. So that's what this inequality is actually saying. So when I have 1 is less than or equal to x, which is less than or equal to 4, really it's saying x is bigger than 1 and x is less than 4. Or keep the c if you like to use the c. The second one is x plus y is less than or equal to 14. What is that with y by itself? What's that equation look like? You get y by itself. Brandon?
Y is less than or equal to negative x plus 15.
Right, good. And then the last one was D and C. But instead, if you want to change it to x and y, D is y, so y is greater than or equal to 2x. So these would be my inequalities from the given information. So we're going to graph this. If you want to put your x and y axis in the center, you can, that's fine. If you want to move it over a little more or move it down a little further, but we need a y-intercept of 14. So wherever you put it, you need to make sure you have enough lines. So I'll just make mine, I'm going to just make mine slightly off.
But we have to draw that.
Yep.
Why?
So drawing your own x and y axis. And then after you have that x and y axis drawn, okay, so now that it's drawn, you're going to see if you can start graphing those lines. So just a reminder, if it's x is greater than or equal to 1, or if it's x is less than or equal to 1, what kind of line are they?
Vertical.
Vertical. So these two should be vertical lines. So I'm going to go where x is 1 and make a vertical line. And then x is also 4. So vertical line. Now, if you don't want to shade everything, that's fine. But if x is greater than 1 and less than 4, I'm in between these two lines. So my solution is going to be somewhere in between these two lines. So if you want to shade that, you can, so that you know your solution should be in there. If you don't need to shade it, that's fine. My third inequality says y is less than or equal to negative x plus 14. So we have to go all the way up to 14. And then the slope is negative, so that means my line should be going down. Whenever a point meets with another line, make sure you're kind of recognizing that point. That's probably going to be part of our boundary.
You're supposed to go all the way down.
You don't actually have to, because we're really just concerned about the two values between the x numbers of 1 and 4. So you don't need to extend that line any further. We just need that boundary between the two. The last one says y is greater than or equal to 2x. Where's that graph start? What's the y-intercept, Isabella?
Your origin?
Yeah, the origin. So 2x means it starts the origin and has a slope of up 2 over 1. But the y-intercept starts at the origin. And again, pay attention to those points that are crossing with your vertical lines. Alright, so I didn't do any shading yet. The top line has to be less than or equal to, so that has to be going down. My bottom line is greater than or equal to, so that should be going up. Remember, you're now going to have a region. So this region looks like what shape? Trapezoid. So you're looking at this trapezoidal region. trapezoidal. So shade it in. It's a pretty good word, trapezoidal.
Yeah, reminds me of buckets.
Oh, yeah.
Because they rhyme. Trapezoidal buckets.
Alright, so there's my shape. And then the very last thing that you're asked to do is just to list the vertices. So this is what like the majority of your homework is going to be like. You're going to draw or graph your lines, create your shape, some kind of shape or feasible region, and then list the vertices.
What do we
So-
have 7 problems tonight?
Only 7.
7.
Maybe 8.
Oh.
8, yeah.
Oh.
4 in the book, 4 in the worksheet. 8.
I thought it was 3 on the worksheet.
I think there's 4.
Oh, Chuck, boom.
So can somebody give me the 4 ordered pairs where the boundaries or the points are, Brandon?
1 and 13.
So 1 and 13, okay?
1 and 2.
1 and 2, all the way down here to 2.
4, 8.
4, 8, and
4,
4, 10. So if I wanted to continue this problem, and we were given an objective function or a goal to figure out something to go on with the type of problem, we would then use these points to figure out like a maximum or minimum value. Questions?
True that.
Alright, so there's one final problem down below. It's back with x and y, and there's only 3 equations to look at or 3 inequalities to look at. Again, draw in your own x and y graph. You don't have to tonight.
Wait,
in your
since there's no
homework.
negatives, can't we just do it like from like
So yes,
the bottom corner be the origin?
Ethan is noticing that because x is greater than or equal to 1, y is greater than or equal to 3, those constraints say that you're not going to have negatives in your problem. So you can kind of make your graph. So you're really looking at most of the first quadrant. That's the part that we need. So x being greater than or equal to 1 is my vertical line. Y being greater than or equal to 3 is the horizontal line. So feel free to shade if you want, but it's going to be in this upper region here. It's not going to be below because we're in the upper part. So anything above this, we're to the right of x equals y. The other inequality is 2x plus 4y is less than or equal to 20. So what would that inequality look like with y by itself? Ethan?
Y equals 1/2, negative 1/2 x plus 10.
Good.
Or no, plus
Plus
5.
Plus 5. There we go. So we're going up to 5. And then down 1, right 2.
It's a pretty small region.
It is pretty small. We could probably count it by 2s. So it's a little triangle.
In our homework, we only have to shade the thing.
Yeah, you only want to shade the area, that's fine. Alright, so this problem, after graphing it wants us now to decide where the maximum and minimum values would be and what they are from the objective function 15x plus 10y. In order to do that, you need the vertices of your triangle. So 2 of them are pretty easy because they actually connect in the corner of a box. So the 1, 3 would be my first point. And then 5, 3. Is that 5? 3, 4, I think I got it. The last one though, mine looks like it connects. You have 4?
I have 4 too.
3, 4. It's 4.
I wrote 4. I
My
don't know.
triangle looks good.
Oh, yeah.
Maybe.
Smaller.
Oh, you know what? I don't think I went down 1.
I had that same problem.
Oh, thanks, Steve. So, what is it down 1 over 2? I went over 3, I think. That's what I did. Nina, did you do the same thing? Did you go over 3?
Yeah,
Yeah.
I think so.
No, you went on B, bro.
Yeah, I went on B, so.
Oh, okay. Alright, so this should be 4 through. There we go. I just found it down. Anybody know how you can find this point right here in the middle?
How?
So when it's not in the corner of a box and it's in the middle between 2 lines.
Well, it's just 0.5.
Why is it just 0.5?
Oh, because it's negative 1/2.
Because it's negative 1/2. So this x value is 1. My slope is negative 1/2. So if you were asked to like algebraically show it, if x is 1 and I wanted to find y, you're going down 1/2 each time. So really the y is 4.5 because of the slope being negative 1/2. So it should be 1/2 less than your previous one. So at the value of 1, my y is 4.5.
I don't understand.
So, Ethan, like this line right here is what?
1.
X equals 1, right?
Wow.
I know, holy smokes. So if x is equal to 1 and I need to get its y value, I would have to take that 1 and plug it into the problem, and then I can get the y value. Have a great day.
You do.
Thanks.
What?
You're tired.
Real